Completed the offset conditions we completed. Last two topics are remaining. One is called what you can say sleeve rate. One topic is remaining. The last topic is your gain bandwidth product. First we'll finish these topics and slowly we'll start what to practice, how to do step by step. We'll try to see the answers. So I'm expecting the next topic you can write the heading. Up to here we completed offset. So last two topics we'll cover. So topic number 3 we are entering here is that is sleeve rate is the next important concept. Sleeve rate. Keep the heading sleeve rate. This is also an important topic, easy to understand, and the formulas are very comfortable. Let's say first of all, I'll write the definition of what is sleeve rate. Okay, write down the definition of sleeve rate. The maximum rate at which an amplifier can respond to an abrupt change of input signal. So what is the meaning of abrupt changes? Sudden change. The best example will be, I define your input like a step. This is called sudden change. Step input. If I give step input to your amplifier, we have some abrupt change. This is called abrupt change. Abrupt, or we can also call it as sudden change. For this type of sudden change input, how your amplifier output will respond, that meaning is being measured by sleeve rates. So sleeve rates will tell about in general how much the output will respond with respect to your input. If your input is changing very fast, I think output also should change in the same manner. But due to the practical reasons, inside time constants, all these issues, maybe whatever the input you are giving the speed, step response is having a sudden change here. The same sudden change we cannot expect at the output due to this practical components called RNC components in your transistors. Let's see now how much maximum frequency you have to go. This is infinite frequency. That's sudden change means infinite frequency. So practically there will be some bandwidth, how much frequency you can do maximum, such that the output will not get distorted. So our interest is to find out F maximum value in the class. How much maximum frequency we can apply the signal such that the output will not get distorted. So how to find this analysis? Let's see. A small derivation I'll show you. Suppose if I take, consider an amplifier. We'll consider an amplifier like this. There's minus, plus side, suppose we have VIN. This is your output. We have some feedback. Here RF and R1. So this is your amplifier circuit I've taken. Okay. So for this amplifier circuit, I want to understand how to find out F maximum for this op amp. I want to know how to find out the F maximum value. How much frequency we have to apply to this op amp such that the output will not get distorted. So how to find this means, first of all, what is the output we'll write? V0 is equal to AF times of input. For a closed loop system, my output is always equals to closed loop gain, that is AF into input, will be the answer. But what is AF here is, where AF is your non-inverting gain, 1 plus R by R1. This is AF from the board. It's a non-inverting amplifier, so non-inverting gain. If it's an inverting amplifier given, you have to write inverting gain. So this is about the issue about AF. Now what is my input here? I'm defining is, my input I'm defining it as Vm sin omega t. I'm defining. Vn, I'm defining it as Vm sin omega t in the class. So let us see the output equation. No? We'll elaborate this equation. So output can be written as AF into Vm sin omega t. This is the output I've written. But what is sleeve rate? What is the formula for this? It is a dV0 divided by dt max. So this is the formula of sleeve rate. You have to find out the change in the output voltage with respect to time of maximum value you have to find out. That's called sleeve rate maximum. If I want to find out, if I differentiate with respect to t, this equation I'm differentiating with respect to t. So then what will be the answer is dV0 divided by dt is equal to AF Vm omega cos omega t. So this is the answer we are getting. So dV0 by dt is equal to AF Vm omega cos omega t, because sin omega t differentiation is nothing but cos omega t. Now you are asking me maximum value. You want maximum. If you want maximum, cos omega t you have. Cos 0 if you take, it will be 1. That is the maximum value. So can I say that this omega t becomes 0, then cos 0 will become 1. So AF you can write Vm, omega becomes omega maximum frequency, and here cos 0 you take, which is the maximum value called 1. At 0 we will get the maximum value. So cos 0 we have to apply. So this becomes AF Vm omega max. So this is our story. This is called a sleeve rate. This is the parameter we are expecting as sleeve rate formula. So sleeve rate is equal to sleeve rate, which is indicated by SR, sleeve rate is equal to AF Vm omega max. So sleeve rate is equal to AF Vm omega max can be written as 2 pi F max. So what is F max here is the formula sleeve rate divided by AF into Vm into 2 pi. So this is the way of finding F maximum value. So after calculating this F maximum value, you will understand for that amplifier how much maximum frequency you can apply. If you apply more than that frequency what I solved in the class, I think your signal will get distorted. So a person should know in an amplifier how much signal frequency you have to apply. That is being measured by concept called sleeve rate. So this is a very simple derivation, and this formula is useful for doing the problems for you. Sometimes they'll ask you Vm to find out, they'll give F maximum, sleeve rate, all these things. Sometimes they'll ask you sleeve rate, they'll give other things for you. So this is the formula of rotation of parameters now. So the formula can be created with a simple steps for you. Yeah. So this is about sleeve rate formula. If anybody say your frequency is greater than f max, if you cross your frequency f max value, the output will get distorted. The V naught will get distorted. The output voltage will get distorted. This is the meaning. So that is the reason for every amplifier we must calculate the f max value. Okay? And then I'll understand how much frequency I can apply to this circuit amplifier. Unnecessarily, whatever you like, if you apply the frequency, it will not respond to you. Then I think you will get distorted outputs. So this is a simple parameter called sleeve rates. It's a very easy topic. Okay? It will not take much time to understand. So make a star mark. This formula is valuable formula for me. This formula, one formula is very valuable. This formula and this formula is one more valuable formulas. With this help only we can solve the competitive questions. These two formulas. So if you complete this, the last small topic is called as gain bandwidth product, how to analyze. That is the final issue. Gain bandwidth product. They're all very small topics. Okay? CMRR is one small topic, and the sleeve rate, gain bandwidth product. They're all basic principal concepts. But offset is having a good design concept. Okay? It has taken good time to understand it. But remaining topics are very simple. So definition also I have given clearly. Just write the definition in a clear manner. Yeah, Harsh Mishra, very good. What about the other students? Shall I go to the final topic now? Sleeve rate is clear, I'm expecting. So all the students, if you have completed, just message me so that we can complete the final topic called FT concept. That is called gain bandwidth product. Yeah, Kamlesh, great. The last topic. So we are entering to the final topic. Great. So I'm coming to the final topic. That is the fourth topic called FT, which is called as gain bandwidth product. In BJT class also we have seen gain bandwidth product concept. Okay. Generally, what is the meaning of FT? Every time is a simple definition. It is the frequency. It is the frequency at which the gain will become unity. This is a very simple concept. Anybody see FT throughout your subjects in BJT class or MOSFET or op-amps, definition never change. FT is nothing but gain bandwidth product or unity gain bandwidth frequency. It is the frequency at which the gain has to fall to unity in the frequency response. Yeah, this is about FT. But op-amp is what type of response? First we'll write op-amp is a low-pass response. It's a low-pass device, we can say. Because high frequencies will have problem, but low frequencies we don't have any problem. So for a open loop op-amp, if you see the frequency response, you can show like this. This is your gain, A versus frequency. I'm talking about open loop op-amp. Open loop op-amp, the frequency response given by the designer is like this. He is showing some response like this, saying that it's a low-pass device. Low frequencies we are getting constant, high frequencies it is attenuating. Here there is AD. Suppose the designer given 10/6 is the open loop gain. Then definitely it will have some bandwidth. We'll take this bandwidth name as FH, low-pass bandwidth. But he has given indirectly some information called FT, which is a unity gain bandwidth product. With the 10/6 falls to unity, at that time your FT is supposed given is 10/7H. Like this in the exam, they'll try to give a response for it. AD is given for your problem is 10/6. AD we are not solving. Designer will tell you how much the gain he created. So this will be given by designer and this will be given by designer. The only our job is how to find out the bandwidth for your op-amp. So for your op-amp, how much is the bandwidth? How to answer this question? The answer find out karna. FT they'll give and AD they'll give in the problems. What is the principle I said in previous BJT classes? Gain into bandwidth. Gain into bandwidth will be same as gain into bandwidth. So you may take here to here the product or here to here the product, that will be same. That is the proof I done in BJT classes. So the gain bandwidth product is constant. So the formula you can write here. 1 into FT will be same as your AD, open loop gain, into FH. So this is the beautiful formula we can apply to solve your bandwidth in the class. So gain bandwidth product formula is gain into bandwidth. This is my gain, this is my bandwidth, will be equal to 1 into FT is telling. That is the story about gain bandwidth product. So now if you want the FH, you want to solve, it is 1 into FT divided by AD. So it is 10/7H divided by 10/6. So FH will be equal to only 10H. So can you see that open loop bandwidth is very less. Open loop bandwidth is very less. Why you are getting very less bandwidth in open loop system is because your gain is very high. I already told you, as the gain becomes more and more, the bandwidth will become very less. So op-amps generally, basically, they will have very less bandwidth. Because of very high gain, they will have less bandwidth. That is the principle I understood from this technique. So gain bandwidth product is constant. Now sir, you are telling that amplifier is having high speed. Amplifiers will work under megahertz. How it is possible? If the bandwidth is very less, I can say that your rise time, what we studied in multi-stages, rise time is inversely proportional to bandwidth I studied. As the bandwidth decreases, the rise time will increase. As the rise time increases more and more, the system speed will fall. But how you are telling in an amplifier, the system speed is very high. In open loop system, the system speed is less. But in closed loop system speed is more, you are telling. How it is possible is, suppose if I make a op-amp as a closed loop now. Closed loop amp. So open loop has been converted to an amplifier, suppose. I converted to an amplifier. So open loop has converted an amplifier means we apply negative feedback. When you apply negative feedback, for example, your gain AF is suppose 10. So after making negative feedback system, my gain came 10 suppose. Because the negative feedback gains are less we can design. AF became 10. AD is 10/6. Now AF became 10. Then can you tell me the bandwidth here with feedback is asking? So closed loop gain for your amplifier you will solve it. 1 plus R by R1 if it is a non-inverting. If it is an inverting, it is minus R by R1. So ACL will come from the amplifier. But What is the bandwidth for closed loop system? If I want to solve this trick, what is the knowledge you must have is, again you can draw a plot. This is a frequency versus A. Again you plot the graph for amplifier now. Amplifier wise, your graph is coming like this. Bandwidth has been increased because your AF is only 10. If AF is 10, automatically your bandwidth, FH of F with feedback will be more. So as the gain falls, bandwidth is increasing. But this answer to find out, we can apply the same principle called as unity gain bandwidth technique. FT1 you can take again. So wherever you want to find the bandwidth, just only the logic is 1 into FT you make equal to that equation. Here, this is the gain, this is the bandwidth that will be equal to 1 into FT. Already FT given in the previous problem is 10 power 7 H. I'll try to use the same data, whatever you have given, same data FT I can write. Only thing is closed loop gain is different now, it is 10. So what is the formula I can write is 1 into FT will become AF into FH of F. What is that F represents is, it's a feedback bandwidth. Okay, feedback bandwidth. So what is the formula here is FH of F will become FT by AF. It is 10 power 7 H divided by 10. It is nothing but 10 power 6 H. So can you see that the bandwidth has been drastically increased? So in open loop system the bandwidth is very small, but in a closed loop system the bandwidth is very high. So if you want to use op amps in a high speed category, don't go for open loop systems, go for closed loop systems. Whenever you're using a negative feedback, then definitely they'll work with high speed because the bandwidth is very high. So like that the characteristics will change from open loop system to closed loop systems. So in the exams you must have the trick of these two formulas. To do this type of questions, these two tricks are very important. So here the principle is 1 into FT is AD into FH. Here the principle is 1 into FT is equal to AF into FH of F. Then what I can do is I can interlink these two formulas now. These two links will explain you. One more link in the class is AD into FH can also be represented as AF into FH of F. So you can create a link like this. You can have a link between open loop to closed loop like this. Sometimes the questions will be on open loop to closed loop. At the time you can interlink these two equations. So this will be the three formulas. Who can understand? They can do these problems very well. And one more thing a person should know. Suppose somebody in the exam they're asking you, can you find out of gain somewhere in higher cutoff frequencies? Above higher cutoff frequencies, somebody will ask you gain. At that time you should have a formula for this. At that time you should have a formula. A is equal to AF by 1 plus J F by FH of F. So this formula is important called low pass transfer function applied. Low pass transfer function. The structure you have to practice always. Low pass transfer function structure. It is 1 plus J F by FH. Here FH become FH of F. Purpose of this is a theoretical approach here. This is a theoretical approach. Whenever the person writes inclined lines like this, we call it as 1 by root 2 we neglect and we teach these classes. If it's a practical issue, we take 1 by root 2. It's a theoretical way of explaining the concepts. At that time, we will take short like this without any bending curvature. We can take exactly 10 and 1 because we are doing some approximation here. Root 2 concepts will not come in these cases. Gain means you should not take by root 2. Gain means you have to take 10 only then. Okay? When you're talking about this type of questions called FT questions. Because in previous class in BJT one time, go back and see your notes. I have written 1 plus FT by FH whole square. 1 I have approximated to neglect. So some issues are going there. Your FT will be always greater than FH. So we done some comparisons there. FT by F beta is much greater than 1. 1 is neglected and root 2 gives us a long line. So this is called theoretical studies. We are approximating to 1 neglected. So that root 2 concept will be missing in these calculations. Okay? Go back and see that notes on time. BJT notes एक बार देखो frequency response. They will understand the trick. Why the root 2 concept is not there here. So these are my basic formulas to cover this concept. So with this we have been covered. The lecture is completed. Just half an hour it has taken to complete these issues. So please copy it. With this I'll stop this video. Okay, it will come as a part 4 video for you. The next is workbook practice. So workbook I'll bring it just 5 minutes. You just note on all these things. Okay, it is in the office. I have to bring the workbooks now. I'll bring the workbooks and I'll be ready to start the workbook problems for you. Meanwhile, please complete all these things.